We believe 5G is an exponential improvement to what we have today. This year is the year that we're going to offer a commercial product to our customers.
In millimeter wave, we have a massive amount of bandwidth.
We're seeing testing speeds of over a gigabit per second, as well as extremely low latency.
It's really high frequency, so everybody thinks it doesn't go very far, but it's a really big pipe, and so that's what allows you to gain the super fast speeds. We're here on top of this parking garage. We're 3,000 feet away from our radio node. The cool thing about this is we did not move the radio node. It's pointing down to serve the customers in that area. But here, even 3,000 feet away, we're still getting gig speeds. So we've driven about a third of a mile away from the radio node. It's located over there behind the trees. We're still getting very good speeds, even though we have foliage in between. Our radio node is tucked in behind those apartments over there. The signal is actually bouncing off of the buildings. Even at this distance with non-line of sight, we're still getting almost a gig. We're here doing our in-building tests. This right here is our CPE equipment. We're going through the wall, over here, also through the window, and our radio is way out there at the tower. And we're still getting really good speeds and signal.
Essentially, what beamforming does is compensate for any signal loss by switching automatically to the strongest beam. The selection of the beam is done instantaneously, so you get really solid coverage using millimeter wave spectrum.
What we've learned over the past year is that the millimeter wave signal is much more resilient than anyone's expected.
This is going out to customers, and it's got the Verizon name behind it, so it has to be reliable and robust. Right now, we're only using half of our spectrum. I'm excited to get this build-out completed and unleash the full potential of 5G.